Okay, so time for a video about exponential and logarithmic functions. And I guess for our class, what we need to learn is how you find the derivative of an exponential or a logarithmic function. But I always think it's better with this kind of thing to give a little bit of a context for what these are. Okay, so here's what I mean. Say that eventually we get to the point in this video where we do something like find the derivative of x times e to the power 3x. Okay, so we'll do that, but what is a function like that? What's it do? That's where I wanted to start. So exponential functions can model population growth. They can model the spread of an infectious disease, radioactive decay, compound interest. There's just, you can, research this yourself if you want to, but there's lots of applications for exponential functions. So here's one of them. This is an actual model that I was able to find, that this will give the population of the country of India T years after the year 2010. Okay, so this is just a model. It's not a crystal ball. All right, all that this equation does is it says that based on how the population is growing at some present time, and this model happens to be from the year 2010, if that growth continues, then this model will predict what the population is in the future. But like I said, it's just a model. It's not a crystal ball. Something could happen to disrupt the way that the population was growing when this model was created. Okay, so that's what models are. They can predict if things continue the way they are. This is the way they'll be in the future. That's what this does. But I thought we'd look at it because these days we hear a lot about exponential growth. Like, I won't name any names or anything, but if a disease were spreading, it might spread exponentially up to a certain point. All right. So I wanted to talk about what that means. So here I thought, well, let's look at some numbers. I mean, when you're doing math, it's usually good to look at numbers. All right. So I did some calculations based on this model to track what the population is various years in the future. Okay. So you can look at the growth of this, like say 7 years into the future, the population is 1240.7 million, and 8 years into the future, it's 1250.6 million. Well, say I do my deltas and I find the change in population over the change in time between these two data points. If you just subtract, you can see that, well, here the population grew by 9.9 million in 1 year, okay? But as time goes on with exponential growth, the growth just gets faster, okay? So I thought, well, let's look further out into the future. Like say when t is 40 in the year 2040, and when t is 41 in the year 2041. Well, look at how the population is growing then. It's growing faster, all right? The change in population over the change in time for these two data points is 13 million per year, all right? Faster. The population's growing faster. And if it continues, the population will grow faster and faster and faster. That's what exponential growth is, okay? All right. Now, so that's an example of an exponential function. Real quick, as far as this model goes, the number e, if you have a scientific calculator, it's so common that the e number will be built into it. You see that key right there? I can do calculations with e. But e is, I don't know. I feel like it's kind of a long story to tell you where that number came from, but it's an repeating decimal, an irrational number. It's about 2.718 if you want to think about what it is, if that would help you. Okay, so let's do something else with this, because my topic is exponential and logarithmic functions. So what's a logarithmic function? Well, say we wanted to do something like this. For the population model that I was just talking about, the one that will give the population of India t years into the future. When will the population be 1628 million? Okay. Well, all right. So this population model gives the population of India in millions t years after the year 2010. Okay. And just with my rough calculations, I could say, well, when it's 1628 million, that's going to be about the year 2041. Okay. So I've got our question answered already. But that's the way I like to do things. I like to start with, when we're learning, say we know the answer to the question, and we're going to learn some technique to verify it, all right? So say, okay, it's going to be about when t is equal to 41. It's going to be about the year 2041. That's my answer to this question. When will the population be 1628 million? How do you figure that out if you didn't know the answer? So let's say that, well, that's our future population of millions. So we'll put 1628 in there. And all these other numbers follow suit, okay? And it's just that I want to know when this is going to happen. I want to know the time. So I'm trying to solve for t, right? So I could do that like this. I'll divide this number. So I get 1628 over 1173.1 equals to e to the power 0.008 t. Okay. Next thing is that I'll get natural log of 1628 over 1173.1 is equal to 0.008 t. Okay, so why that? There's our logarithm. That's natural logarithm. So the reason for that is that here's the meaning of any logarithm. If I say log base 2 of 16 is equal to 4, what that says, the information that's given in this statement is that 2 to the 4th power is 16. And that's true, right? But there are just different ways of saying that. For all logarithmic statements, this number, if raised to that power, should give you this number here. So 2 to the 4th power is in fact 16. Okay? So natural logarithm, like say I have natural logarithm of some number, all right? For us right now, it doesn't matter what it is. That's just a logarithm like this one, but the base number there is e, okay? So do you see how I got from here to here? This is really like saying logarithm base number e, 1628 over 1173.1 equals 0.008t. It's like that, all right? Because this would say e, if raised to this power over here, is going to give you this number there. And that's where we came from, isn't it? E to the power 0.008t is equal to 1628 over 1173.1, right? Okay. So, but it's just like log base c has this special name and notation called the natural logarithm. If I needed to do calculations with it, I've got right there the natural logarithm function is in my calculator and probably yours too. Now, so I'm one step away from my answer. That's just a calculation that a machine can do, a calculator can do. To solve for t, I got to divide by 0.008. So my answer will be that the time in question is natural log 1628 over 1173.1 over 0.008. All right. And I'm expecting that to be about 41 when I solve for t, okay? About roughly 41. So let's see what we get. All right, so let's see. So I get natural log 1628 divided by 1173.1. Okay, so see I got that, all right? And then I divide that by 0.008, right? And then I get about 40.96. Yeah, that's about what I was expecting. 40.96. What does that translate to? Well, so t being about 41 translates to the year 2041, when the population is, yeah, it's about 1628. So that's the answer I was expecting. I just wanted you to see what we use logarithms for. That's obviously, this is not the whole story of logarithms. It's just what I can tell you in 10 minutes, let's say. Okay. So there, I got that. And I'm going to brag a little bit that, yeah, I knew that's how it was going to work out. Okay. All right. Now let's talk about how you find the derivative of an exponential function. Okay. So like this one. Here, if I was going to find the derivative of that, I would need to use the product rule because it is a product of two functions. It's x times e to the 3x. But let's establish a rule first for that e to the 3x power. Say that y is e to the u power. And I hope by now you know that anytime that we say, like in a rule, we say u, we mean that u is some function of, say, x, the variable x. Y prime is going to be e to the u power times u prime. Okay? Or you might see it in different places like this. Right? They mean the same thing. The derivative of e to the u power is e to the u power times the derivative of the u. Okay? So for this one, let's do a little bit of math to get started. Okay? What is the derivative with respect to x of e to the 3x power based on this rule I just gave you? Say you had just that by itself. That would be e to the 3x times, what's the derivative of 3x? It's just 3. So in other words, 3e to the 3x. So there's our derivative of e to the 3x. Now, in order to find y prime here, I would have to use the product rule. F prime g plus g prime. What's the derivative of e to the 3x? 3e to the 3x times f. So there is the product rule. Okay? Look at that initial problem. Realize that I would have to use the product rule, and there it is. So we could write our final answer something like this. I wrote the one there just to emphasize how I was using the product rule, but e to the 3x plus 3x e to the 3x. Okay, that will be okay. But you might see it simplified a little bit further. Sometimes people are fond of factoring their answers. So you should be aware that that could be done. Wouldn't this be the correct factorization of what I had? E to the 3x times 1 and e to the 3x times 3x, and it's the same thing. Who knows like which one of these you're going to have to give, but I told you about both of them. All right. Okay, what about this one? Okay, now, through the process of doing this, I'm going to have to find the derivative of e to the x power. What would that be? Let's see the rule right there. So let's establish something. Hint. The derivative with respect to x of e to the x is just e to the x times 1, isn't it? It's e to the x power times, what's the derivative of x? It's just 1. Okay, so the derivative with respect to x of e to the x power is e to the x power. Let's do this problem now. I would have to use the product rule individually twice. Like when I find the derivative of x squared e to the x, that's product rule. Let's do that. Let's do that part first. 2x e to the x plus e to the x times x squared, right? F prime g plus g prime f. We're done with that. What about this minus? Carry it down. And that minus would apply to the derivative of this, but that would require product rule. What's the derivative of 2x e to the x? That goes in here. this minus that I carry down applies to all of it. So that'd be 2 e to the x plus e to the x times 2x. Okay, so that minus applies to all that. What about this last one? Carry down the plus. What's the derivative of 9 times e to the x? Well, it's 9 times whatever the derivative of e to the x power is, which is e to the x power. Okay, so we got a lot of stuff here. Let's clean it up a little bit. So I got 2x e to the x. This, let me go ahead and write that x squared e to the x. All right. Then this minus applies in there. Get minus 2 e to the x. And then minus 2x e to the x, right? Plus 9 e to the x. All right, so that's everything. I see some canceling. 2x e to the x right there. Negative 2x e to the x there. What's left? Well, I can't really do anything with what's left. Let's see. X squared e to the x minus 2 e to the x plus 9 e to the x. That's what's left. And I guess those are like terms, aren't they? Yeah, they are like terms. So my final answer, x squared e to the x. What? 9 apples take away 2 apples. That's kind of how it is. It's 7. Okay. All right. So I could give you that. Who knows? Maybe you'll need to factor it. E to the x is common to both terms, so I could do like that, right? Okay. You know, for me personally, I mean, I guess it doesn't really matter, but sometimes people, they prefer the factored form. I guess it is a little simpler than that one, but it's no big deal to me. Okay. All right, so we got that one down. Let's see what else. What about a logarithm problem? What's the derivative of natural log of something? Well, let's, as we always do, let's start with a rule. Okay. So my rule is that if y is natural log of u, or like every single time that I write down u in the context of my rules, u is some function of x, such as this entire mess right there is a function of a formula that involves x. Y prime is going to be 1 over u times u prime, or you might see it as 1 over u times du over dx. Either way, they say the same thing. It's 1 over u times the derivative of the u. That's what we want for this. Okay, I could do this one the way it is, but I can also simplify it. So let me, I'll have to give you another rule, I think, to make this easier. For logarithms, let's say rule 1 right here, and a second rule that is just algebra. Okay, it's not calculus, it doesn't really have anything to do with derivatives, but if we have log base b, a logarithm of any base, of one thing divided by another thing, that as it is can be simplified as log base b of m, whatever that is, minus log base b of n. And maybe these are simpler by themselves than to have all that together. All right. I think that we should approach this one this way and then find the derivative. Okay. And by now you know that, sometimes we simplify things before we start working on them. So I'll get, this is natural log of 1 plus e to the x minus natural log of 1 minus e to the x. Okay. All right. So let's find the derivative of, let's find y prime based on this. So y prime is going to be 1 over u. Okay, and what's the derivative of that 1 plus e to the x? What's u prime? That's natural log of u. Here's 1 over u. What's u prime? It would just be e to the x, right? Yeah, what's the derivative of 1 plus e to the x? It's 0 plus e to the x. All right, minus, what about this one? 1 over 1 minus e to the x, 1 over u. What's the derivative of 1 minus e to the x? 0 minus e to the x. Okay? What's the derivative of 1 minus e to the x? 0 minus e to the x, just negative e to the x. All right, so that is this rule, plus knowing that the derivative of e to the x is e to the x. We discussed that in the previous problem. All right, so y prime. Okay, so I get e to the x, 1 over 1 plus e to the x. And over here, I get, two negatives, so I get e to the x over 1 minus e to the x. Okay. And, well, those are different. I don't think we can combine them or anything like that. Let me think for a second. No. We can end it right there. Wait a second. Okay, so here, I think we can add these together. Okay, we can combine those into one thing. Let's say that we want to add them. They're fractions. They have different denominators. The common denominator would be the product of these. Okay, so I'll multiply this fraction by 1 minus e to the x. Okay. And then down here, if I multiply by 1 minus e to the x, I'll get 1 minus e to the 2x. Okay. Let me show you why that is. If I get 1 plus e to the x times 1 minus e to the x, using FOIL multiplication, 1 times 1, 1 times minus e to the x, 1 times plus e to the x, right? So first, outside, inside, and then here last, that's negative. What do you do when you multiply like things? You add the exponents. So the middle cancels, and I get 1 minus e to the 2x. What about over here? I'd multiply by 1 plus e to the x. Up and down. I'll get e to the x, 1 plus e to the x. And down here, I'll get that same common denominator, 1 minus e to the 2x. Okay, so at this point, I'll add them, but then I notice there's some canceling. Okay, so say I add them. All right, I'm going to have a lot of stuff. What do I have up there if I multiply that out? E to the x minus e to the 2x, right? And what do I have over here if I multiply that? E to the x plus e to the 2x over that common denominator, 1 minus e to the 2x. So, okay, now we reduced it all the way here. Those cancel. These can be added because they're like terms. So it's 2e to the x over 1 minus e to the 2x. All right. So I was too hasty when I boxed that. I'm sorry. We can reduce it a lot. This is a lot simpler than that, in other words. Okay. Anyway, all right. So I gotta admit that I was too much in a hurry. All right, I thought I had it, and then I realized, wait, a lot of that stuff can be combined and canceled if we add these fractions together with a common denominator. Okay, so we got that one. That's how we'll treat logarithms, natural log base e. Okay, so let's see something else. What about this? Y is equal to 2 to the power negative 3x. That's kind of like, it's an exponential function, sort of like this one, where you get a number like e raised to a power, but the number that's being raised to the power is 2, okay? So we need another rule for that. In other words, I have the rule for what the derivative of e to a power is. I got that one, and I need a rule for some other number to a power. So like y is equal to a to the x power, something like that. So let's establish a rule for that. So the rule for y is equal to a to the x power. A is some constant that is positive, let's say, like 2. Then y prime is going to be, oh, look at me. y prime is going to be a to the x power. Okay, I'll get there. Okay, I needed to put u. So if y is equal to a to the u power, y prime is going to be a to the u power natural log of a du dx. Okay, and if you want to think of the du dx as u prime, you can think of it that way. So that's the rule for this one. A to the u power. Some constant that's positive, such as 2, to some power that is a function of x somehow. All right? So for this one, y prime is going to be like this. 2 to the 3x power, 2 to the negative 3x power, natural log of 2, then times u prime, where u is negative 3x. That's negative 3, right? Okay, now, so just take a second to look at that. Here's the rule for that problem, and then here's me like writing it out exactly as it is there. So look at that, make sure that you can see. Okay, so say we got that. Here's the simplifying that we can do, all right? Y prime, let me say it's negative, all right? And I have a 3 natural log 2. And then down here I get 2 to the negative 3x. Okay? I'm sorry, 2 to the 3x. Right? Say I move that because its exponent is negative, and I put it down here. So we can do that. We've worked with exponents that way before. Okay, so anyway, so say I get that. Now this part I can do a little simplifying with. So look at it like this. 2 to the 3x. Can you agree that's the same thing as 2 to the third power, then subsequently raised to the x power? Same thing. What would you do if you had this? 2 to the third power, then to the x power. Well, when you raise a number to a power and then to some subsequent power, you multiply them together. So yeah, you would get this. But I can say, well, that's just an 8 and have one less number. So let's give our answer like this. Negative 3 natural log 2 over 8 to the x power. Okay, so yeah, we can do it like that. That's one way to simplify it. Okay. Now, I don't know. I mean, I wish I could say that there's just always just one answer as far as how things are simplified, and that's always how it is. Another thing that you could do, and I need to mention this just in case that you run into it. Say you have a number, so let's say p is a number, times a logarithm of some base of something. If you wanted to, you can apply this number as a power on that one. So that is another thing that we could do with this. I can't say that this is exactly what you'd run into, but that would make it like this. If I said, okay, well, there's my rule, that number can be the power of 2. I could look at this like it was just natural log of 2 to the third power, which is 8. So I want to give you both of those, all right? And put an or, because like I said, I can't say that for online homework that you're always going to give this answer or that one. If you, for whatever teacher you have, I can't say that you're going to give this one or that one. But just, can you see how I got here? And can you see that these are the same? If I can do that, then I guess that's okay. All right. Anyway, so let's do one more problem. And then I think we got all the rules covered that we need to talk about. So say we got this, log base 6 of something. Okay. And that's kind of like, let's say just for the sake of context, that's kind of like this one. It's a logarithm. Here, when I had natural log, that's logarithm with a base of e. And its rule is like so, okay? But this is logarithm with a base of 6. It's some other number. So we need to establish a rule for that. Say y is equal to log base b of u. Or again, u, like every other time, is some function of x. Y prime will be 1 over u natural log of b times u prime. Okay? That will be our rule for this one. So, okay, so how would that play out? Y prime, I know there might be some simplifying when we do this, but based on just that rule, okay, and nothing else, this will be 1 over x squared minus 3x natural log of 6. Okay, then times u prime. What's the u? X squared minus 3x. So that's going to be 2x minus 3. Okay, so take a second, look at that. I mean, you gotta grasp the rule, and you gotta see what I did here. So just take a second, look at that, make sure you see it. Okay, so next question, what can we do with it? This time, I guess this is it. I mean, I can multiply these together. 2x minus 3 on top there, right? And then, oh, sorry, I didn't mean to write 3x. 2x minus 3 over x squared minus 3x times natural log of 6. All right, that's as far as what we got. I don't think we can take it any further than that. Okay, but we got the rule. Understand the rule. Always take the problem and make it obvious to yourself which rule you got to use. You shouldn't be thinking too much about the rule. The function should match the way that I wrote the rule right away. It should be pretty obvious.